Hey, hello, folks. My name is Dr. Evan Tyler, and I am a transgender man and an astrophysicist, and I work as an assistant professor of physics at the College of St. Scholastica. I'm here to talk a little bit about my research, which is in the topic of space weather. So, when most folks think about weather, you're generally thinking about the weather of air on Earth, so air temperature, wind speeds, cloud cover, that sort of thing. But here on Earth, we also actually experience space weather, which is changes in the condition of the space around our planet. We're surrounded by a space environment which is full of free electrons, protons, heavy ions, and electric and magnetic fields, all of which can experience weather. The primary driver of space weather is the sun. At all times, the sun is expelling energetic, high speed particles, which we call the solar wind, which you can see in this satellite image here. Fortunately for life on Earth, the Earth has a magnetic field which acts as a shield against the solar wind, deflecting the dangerous particles away from our atmosphere. But the barrage of wind jostles our field and shakes it around and causes changes in its strength and configuration. Reconfigurations of our magnetic field are pretty common, and we call them magnetic reconnection. These release a large amount of energy which can travel towards the Earth and affect us on the ground. This energy release can cause beautiful phenomena such as the aurora borealis, but it also has harmful effects. It can damage our satellites, disrupt our radio communications, and even create strong ground currents which damage our power grids and cause massive blackouts. In order to study reconnection, multiple space agencies have launched satellites to orbit the Earth and measure the conditions in space directly. We want to know what's going on right when and right where reconnection happens. I primarily use spacecraft called Cluster and the Magnetospheric Multiscale Mission, otherwise known as MMS. These spacecraft can directly measure the density, speeds, and temperatures of the particles in space during reconnection events, and I use this data to calculate the energy release that's occurring. I'm interested in knowing how the energy release is being distributed. For example, how much energy is going into speeding up the particles and how much is going into heating up the particles. I also want to know which particles are getting the energy. Is it the electrons, the protons, or the heavier materials like ionized helium or, in this image, ionized oxygen? Heavier ions have often been neglected in previous studies because there's just not as much of them out in the space around Earth as protons and electrons. But I'm interested in understanding how the presence of oxygen, especially, changes the energy released during reconnection and why. An earlier study I've done shows that oxygen can, at times, carry away the majority of the energy from the reconnection region, although in many events it carries away almost none at all. We're not really sure yet why this difference happens and what the conditions are that cause oxygen to gain a lot of energy. My hope is that by shining some light on when, where, and why oxygen is gaining energy, we'll have a better understanding of reconnection in general, and therefore have a better understanding of the type of weather that we experience on Earth that comes from space.